Okay, so for this warm-up, this is a really good warm-up. It says find the measurement, okay? So the measure of angle 1. Using the information for this problem, angle 1 is right here. It is vertical to this angle, which is 31 degrees. So angle 1 must be 31 degrees, okay? Angle 2 we have less information about, but we can still figure it out. We have to use the fact that this is 90 degrees, and this angle lies on this line. So when you combine this angle, which is 90, with angle 2 and 31, you should get 180 degrees. In other words, the measure of angle 2 plus 31 degrees is equal to 90 degrees, okay? Because if there's 90 used up here, we have 90 left to work with, so 2 and 31 should add up to 90. We subtract 31 from both sides. We're going to get the measure of angle 2 is equal to 59 degrees. So this is 59 degrees. We look at angle 3. Well, angle 3 is easy. It's opposite angle 2, so it's vertical to angle 2, so those two need to be congruent. So this also needs to be 59 degrees. And then angle 4 is vertical to the original 90-degree angle, so this one also needs to be 90 degrees. Right, so chapter 5, section 2, congruent polynomials, okay? Congruent figures are two figures that have the same shape, size and shape. All their corresponding parts of one figure are congruent to the corresponding parts of the other figure. In order to call two figures congruent, every single thing about them needs to be the same. So notice there's an angle that matches for each of these for all three. There's a side that matches for each of these for all three sides. Okay, so those two triangles are congruent because all of their parts are congruent. Okay, so congruent figures. Let's identify the congruent parts. So corresponding angles. Okay, let's match up which angles are congruent. Well, let's start with the measure of angle A. If we're saying congruence, we should say angle A is congruent to, and I see that angle A is the same degrees as angle D. So it's congruent to angle D. The second part, we should have three congruence statements here. We're going to say angle C is congruent to angle F. And the last part we're going to say angle angle B from the first triangle is congruent to angle E. And how I'm saying all of these, guys, is I'm matching up the angle markings. So A had 1, C had 2, and B had 3. So match them up. E has 3 as well, so E and B are the same measure. F and C both had 2, so those are the same measure. And D and A both had 1, so those are the same measure, okay? The next one, we're doing corresponding sides. So check it out. I noticed that CB, the line segment, which is the side of the triangle, is going to be congruent to the other side that has the single congruence marking. That would be EF, okay? Now, the next part is to match up the second one. So BA is congruent to ED.
Have a good weekend, teacher.
So let's take a look. AC would be the next segment, and that one has 3 marks on it, so that one would be congruent to none other than DF. So we've got 3 congruent sides, 3 congruent angles. That is enough to say that the two triangles are congruent themselves. But now, the most important part of the lesson, make sure when you are writing your congruent statement saying that two triangles are congruent, you need to match up the corresponding angles. So A was congruent to D. Those two have to be in the same spot. They come first. Notice that. B was congruent to E, so B and E come second. And then lastly, C was congruent to F, so C and F come last. You could have put the first triangle in any other order. Take a look at it. We've got BCA, but you have to reorganize the second one if you reorganize the first one, okay? All of the angles need to match up. That is super important. Okay, the third angles theorem. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. If angle A is congruent to angle D and angle B is congruent to angle E, then angle C must be congruent to angle F. This angle must be congruent to this angle, okay? Now, I want us to do a little like refresher. Let's say we wrote triangle CBA, and we wanted to say that it's congruent to angle DEF. We have to organize our letters in a certain way so each of the angles matches up. We started with C. The angle congruent to C is F, so we need to start with F. Next, we move on to B. The corresponding angle to B is E. And then lastly, we move to A. The corresponding angle to A is D. So we must write our congruence statements in this way, otherwise they are wrong, okay? A few slides. Do you remember when two angles of a triangle are congruent? Then the third angles. All right. Here are some properties of congruent triangles. The three that you guys need to know are the reflexive, the symmetric, and the transitive. And those work just like those properties would work when we talked about their other properties, right? Of congruence or of equality. You can reference any one of those, but remember, if reflexive is just the same thing equals the same thing. Symmetric is a line of symmetry, so you can reverse the order. And then transitive is if A is congruent to B, B is congruent to C, then A and C are congruent. And let's go back to the third. Okay, complete with always, sometimes, or never. An acute triangle is blank congruent to an obtuse triangle. That would be never. And the reason is because if you're acute, you have no angles that are obtuse. And if you're obtuse, you have one angle that is not acute. So they can never be congruent to each other. In order to be congruent, everything needs to be the same. A polygon is always congruent to itself because it has all the same parts. A right triangle is blank congruent to another right triangle. This one is sometimes, because you could have a right triangle that looks like this and a right triangle that looks like this. Both right triangles, but definitely not congruent. Those are not the same figure, okay? If ABC is congruent to XYZ, then angle A is blank congruent to angle Y. This one would be sometimes, because angle A and angle Y do not line up, right? But what if you had an equiangular triangle where all of the angles are 60? Then you know that all of the angles are the same for A, B, and C, and all the angles are the same for X, Y, and Z, so they are congruent, but this is a sometimes, okay? Because it could happen, but it doesn't happen all the time. Now, if angle ABC and XYZ are congruent, then angle A is always congruent to angle X because they are in the same position. They are the first letter. So those always have to be congruent in this third angle. Example 2. In the diagram, ABCD is congruent to FGHK. Notice the order. Find the value of X. Well, let's find X in our diagram. X exists right here. It also happens down here, right? But that includes a Y, so we don't want to deal with that one yet. We want to deal with the X, and then we'll figure out the Y later. Now, the X that we're given is in relation to this side, which is from F to G, okay? So locate FG in your congruence statement, and it's the first two letters. Look at the first two letters of the other congruence statement, and then find that side on your image, AB. The length of AB in this image is 9 inches. Those two need to be congruent, so they need to be the same. So the equation we would set up is 3x minus 6 equals 9. You would just add 6 to both sides. You would get 3x equals 15, divide by 3, and you would get x equals 3. I'm sorry, not 3, 5. So if x equals 5, now it says find the value of y. Well, now if x is 5, we can plug that in there. We get 20 plus 2y, okay? Now angle K, look where angle K lies. It's right here at the end. Needs to be the same as angle D. Angle D over here is 44 degrees. So we set those two equal to each other. So we say 44 degrees is equal to 20 plus 2y. From here, we're going to subtract 20 from both sides. We're going to get 24 equals 2y, divide by 2, and we're going to get 12 equals y. So y is equal to 12. And then it says write the congruent statement in another way. Well, let's just reorganize it. So let's write it as DCBA is congruent to KHGF. All I did was I reversed the order. I wrote it in the opposite way. I started with D, went to C, went to B, went to A, and I started with K, went to H, went to G, and went to F, okay? Now, when you're dealing with triangles, okay, you get a little bit more freedom, but when we have 4 letters, you have to remember the order is crucial. If you started with D, you could not go straight to B because they're located on opposite sides. You would either need to go to A or you would need to go to C. And then automatically you would go to B next, okay? So you would have to go D, C, B, A. Same thing with, if you started with K, you could not go immediately across the image to G. You would have to go in order, so either to H or to F next, okay? In this case, we would go K, H, then to G, then to F. And then you could connect it back to K, because the last letter will circle back to the first one. Learn theorem. Okay, example 3. Maggie took the piece of fabric STUV shown in the diagram and cut it on a diagonal to make a scarf for her and a friend. Are the two pieces the same size and the same shape? Explain. Well, we need to match up all of the angles. We need to match up all of the sides, okay? Let's start with the sides because that's the easier one, okay? So we've got 2 triangles. We've got SVU, and we've also got STU. I'll put that one in blue. We're trying to prove that those 2 triangles are the same. So we need to start with the angles, okay? Let's say angle V is congruent to angle T, okay? Both of them are 90, okay? So that's one angle. We can say angle 2 is congruent. So angle 2 lies in the blue triangle. We need to prove that that's congruent to either angle 1 or angle 3. Now, how we do that is you have to remember that all 4 of these angles are perpendicular, right? There's 4 perpendicular lines. So all of them are parallel to the lines that are across from them, okay? So TU is parallel to SV because they're both perpendicular to ST. ST is parallel to VU because they're both perpendicular to TU, okay? Now, if we have 2 perpendicular or parallel lines cut by a transversal, we know that alternate interior angles are congruent. So angle 3 and angle 2 would be congruent. So we would say angle 2 is congruent to angle 3. And then lastly, let's take a look at angle 1 and angle alternate interior, also congruent. So angle 1 is congruent to angle 4. Okay. Now, we have to take a look at the sides. Now, ST as a side is congruent, and that one's obvious because it's also listed with a double congruence mark to VU. Then we've got SV is congruent to TU. And now the third side is SU. Now that is a shared side between the two triangles, so it must be congruent to itself. So we would just write SU is congruent to SU. That is the reflexive property of congruence. So we've proved 3 of the angles are congruent. We've proved 3 of the sides are congruent. We have enough information to write our congruent statement. So we would write triangle. Let's just write the blue triangle, STU, in no particular order. But now we have to be super careful when we write the congruent statement for the red triangle, okay? The red triangle is SU and V. Now, let's take a look at the angles that we wrote that are congruent. Angle V and T must be at the same spot. So V must go in the middle, okay? Because T went in the middle on this left side. Now, S and U are shared, right? Both of our triangles go through S and U. But look, angle 2 is in the blue triangle, and that one was at point S. So this one's angle 2. What was the corresponding angle in the red one? It was angle 3, which happens at point U. So our first letter of the next congruent statement should be U, V, and then angle 4 and 1 were congruent. So therefore, U and S get switched for the next one.
Madison
So the last letter is
come to
S.
the front. Your ride is waiting. Madison McGinn, please come to the front. Thank you.
So we would just so okay. Example 4. Given SV is congruent to RV, TV is congruent to WV, ST is congruent to RW, and angle T is congruent to angle W. Prove that triangle STV is congruent to triangle RWV. Well, let's figure it out. So let's just mark our diagram with all the information that we're given, okay? So it says SV is congruent to RV, so put a congruence mark here. It says TV is congruent to WV. So these two are congruent. We don't know that they're the same length as VR and SV, so make sure that you use a different congruence mark, either 2 or 3 markings. ST is congruent to RW, and angle T is congruent to angle V. So we've got 3 sides, so we don't need to prove any of the other sides, but we do need to prove that WVR, angle WVR, is congruent, that's this angle right here, to SVT. And we also need to prove that angle S is congruent to angle R, okay? Now, we need reasons for each of these. WVR is congruent to SVT because they are vertical angles. And angle S is congruent to angle R because of a theorem that those two are congruent by the third angles theorem. So these two are congruent, and then these two are congruent. And we're done. All right, so on the last slide, please let me know what is puzzling you the most and then what you were most successful in for this lesson.